this is Formulas 2. You should have already reviewed pre-formulas in Formula 1. Now, let's look at this. Period 4. Period 4. What do you notice about period 4? The first thing I hope you see is you have the normal 1A, 2A through 7A. These elements form octets, 1 plus 2 plus 3 plus 3 minus 2 minus 1 minus. But you have this group of 10 elements in the middle. These elements are called the transition elements, or the transition metals. Transition metals. The first thing I'll tell you about them is they don't determine or build ions based on octets. They do not form octets. And secondly, I will tell you that some of these elements have more than one charge. So we have a problem, how to deal with this charge. Well, this problem was dealt with by a man by the name of Alfred Stock, a German chemist, way back in about 1919. And Stock established a system, and I think let's call it the Stock system. Stock decided to simplify this process by using a number attached to the element. For instance, if you were write iron bromide, you wouldn't know whether the iron, you would know bromide is 1 minus, but you wouldn't know whether iron was 3 plus or 2 plus. So he simply said, let's put a number in there, and later on it was changed to a Roman numeral. And it would be with a parentheses, we put, and I'll use yellow here just to get that out. Say iron 1 bromide, or iron 2 bromide, or iron 3 bromide. There is no iron 1, so we'll put 2 there. Iron 2 bromide, or you could have iron 3 bromide. And we're not working at the color I normally like to work at, but we'll change that. So the formula would be Fe for iron, Roman numeral 2 would be 2 plus, bromide is 1 minus, so it would be FeBr2, all right? 2 1 minuses, it goes with this plus. This one would be Fe 3 plus. Now think how simple the Stock system is. The Roman numeral just tells you the charge. It'd be FeBr3. It's 1 minus. Incidentally, when you write formulas, you can put these charges in, but you could erase them when you're finished, because the real formula here is just FeBr2 and FeBr3. The charges are just there so you can add them up so they're equal to 0. A second example of a compound could be copper. Copper, you notice copper is 2 and 1. You could have copper 2 bromide, or we'll just change it to oxide. And we could have copper 1 oxide. Now if you notice the picture up here, you'll see copper 1 oxide and copper 2 oxide are entirely different colors. One is orange and one is black. So copper 2 oxide would be Cu2 plus. And the oxide is group 6A, 2 minus. So the formula is CuO. Copper 1 oxide would be Cu1 plus, oxygen 2 minus. You have to have 2 copper ions for every oxygen, so it would be Cu2O. Now, there is Latin names for some of the very old elements, like iron and copper, and it's based on the Latin name ferrum for iron, And therefore there was a system before the stock system that the higher oxidation number, you take the ferrum, the base, and add, instead of RUM, be IC. You add IC for the higher oxidation state and OUS for the lower. So this would be called ferrous bromide, and this would be called ferric bromide. And the same thing as copper, cuprum, the Latin name. So this would be cupric oxide and cuprous. So you see the problem with the system. It doesn't tell you the charge, because here the higher charge is a 3+, and here the higher charge is a 2+. Okay. So one of the problems you're going to run into, sometimes you have to work backwards. For instance, if you're given this formula. Okay. CuSO4. Put a capital C. CuSO4. What is the name of that substance? Now we're working backwards. See, we're starting with the formula and we're running the name. Well, you have to work backwards with the formula. Sulfate, you know, is always the same. It's a polyatomic 2-. So the copper has to be 2+. So this is called copper 2 sulfate. And let's try another one. Let's say we have this formula Fe2O3. Now oxygen's not up here. You're going to have to be knowing by now oxygen is in group 6, 6A. It's a -2 charge. So 3 times a -2 is a -6. So this has to be a +6. Each one has to be a +3. So this compound would be called iron 3 oxide. Iron 3 oxide. Okay, see how we do, working backwards. Now let's try this one. If you write the formula, if I ask you to, what is the formula for this? Zinc sulfate. You do not say zinc, see is a 2+ up here. You do not say zinc 2 sulfate because there's only one charge. You only use the stock system when you have 2 charges. You don't use it for scandium, titanium, or zinc. Also in the next period, silver, cadmium, transition metals only have 1 charge. Okay? So let's try one more. Let's write this formula. What is the name of that substance? Now, you have a couple problems. Nitrate, and this is copper. The nitrate is a 1-. 1-. Copper has to be a 1+. So this would be called copper 1 nitrate. Okay, so we worked some more ionic compounds. In the next session, I want you to see we're going to work with some molecular compounds. This will be called Formulas 2, the next section. And we'll stop now.